All right. Hi, everyone, and welcome to this talk about infrastructure drift, infrastructure as code, in the end, DevSecOps, and obviously drift CTL, drift control. So in this talk, I will briefly define what is infrastructure drift, sorry, and what we learned basically the hard way, just the kind of stories we just had with Jakub right now. And then it's going to take just like 5 minutes for the context. And then it will be a lot of fun live demos and stories like from the trenches, like it was mentioned. So it will be a very hands-on live talk. So don't hesitate, interrupt, ask questions on Discord, etc. I will be very responsive. So yeah, thank you for attending. So basically, last year we were working on a GitOps platform to support infrastructure as code. So all the infrastructure as code and all the tooling around that and all the best practices. And at some point, we wanted more feedback. We looked for feedback to build, the next features. What are we going to focus on? And we interviewed our users and a lot of other DevOps, SREs, some CTOs, etc. And the most important pain those people reported to us was around infrastructure drift. It took different names, took different forms, but in the end, it was the visibility of what's basically living outside of your Terraform configuration. So if you have only one thing to remember from this talk, it's that basically almost everyone experienced infrastructure drift recently, and that drift can have major consequences, including security. That's in the end the reason why we built this open source tool called Drift CTL, Drift Control, call it like you want, Drift Cuttle as well. So I'm Stephane. I'm basically pretty much everywhere on the internet under the name of Jourdan. I've been around infrastructures for the past 20 years. I co-founded a bunch of companies in Canada, in Europe as well. And I co-wrote a book called Infrastructure as Code like 5 years ago when I was in Montreal. But more recently, I'm the happy co-founder of the open source tool Drift Control, and the team is really wonderful. So after talking to, as I said, like 200 people, maybe, we had to come up with a common definition of infrastructure drift. So basically, the definition we came up with is what happens when the reality and the expectation don't match. And basically, you can call it as well, oh my God, when things go wrong and they were not supposed to. So according to this definition, in this slide, you have your AWS account on the right with a ton of actual resources, live resources, costing you a lot of money. And maybe only part of it is correctly managed by Terraform. That's the left part of the slide. And the diff between the two, basically, the diff is the drift. So what are the causes of drift? There are many. There are many causes, but the major ones are obviously manual changes made directly when you log in on the AWS console and you click over things and change stuff. That's the major source of drift, obviously. But there is many other sources like authenticated lambdas, authenticated microservices, all the scripts that run every night that snapshot the disks for some backup purposes. Or maybe you have scripts scanning for stuff and modifying other stuff overnight, etc. All those authenticated stuff can be a source of drift. We'll have some examples after that. We can have as well maybe another team working with another tool. You are using Terraform, but maybe this other team is using CloudFormation or Pulumi or whatever, or maybe that Boto script in Python because it's so cool. or maybe it's just that because you have an AWS service not yet available right now in your Terraform provider. The latest version doesn't support the latest new service, so you have to do it another way, and it creates a drift by itself. You can have as well a new project starting on a new cloud provider, like you are maybe all the production systems are on GCP, but right now you have to do it on Azure. And well, you don't know Azure that well, and possibly you do not have the time to automate it properly. So it can create drift as well. So yeah, basically all those activities and many others, they are all authenticated, and they are all sources, and they are all causes of drift. So it could be like no big deal, and maybe we could live with those drifts. Like problem, the problem is that misconfiguration can lead to well, security issues that you do not even know about. Like on this slide, we see that the NSA recently labeled poor access control and misconfiguration as top issues. And definitely, I really think you want to know about the unknown stuff running in your cloud, your cloud provider, sorry, because if you don't know about it, how could you fix it? So basically, the idea here is to lighten, to shed light on the blind spots for all the unknown resources on your accounts, and those that are not under control with Terraform, because we can have a lot of discrepancy for everything that's around Terraform. So only then I think you will know about misconfiguration, and only then you'll be able to address or fix the issues. So that was about it for the 5 minutes of context about the sources of drift and why does it drift, etc. And now it's more the second part, like with stories. They are simplified for the talk. They are like it would take us hours to have the whole context at each time. They are either directly from us, like the story from last Friday I just told Jakub at the beginning of the talk, or from our close friends and colleagues. We have hundreds of them, but those are all obviously real. And among the stories, I will show each time how driftctl, drift control, our open source answer to those drifts helped in this situation. So the first of the three stories I'll share today is about a team that had an authenticated microservice. It was they just released a new version. It was Friday evening, and during the weekend, something went wrong. And basically, the on-call team they had to fix that, and they started to look at the Terraform code. It's here. So for those of you who are not very familiar with Terraform, let me share my terminal. It's going to be easier. All right. So for those of you who are not very familiar, Terraform works with basically resources, and you can create an IAM user here with the name, tags, etc. You can create an access key and link it, attach it to the user here. So basically, the access key in this case is for this user, and the team in that case attached a policy directly to the user for read-only access. So it was like secure, that microservice just needed to access read-only stuff on the AWS account. So basically it was pretty locked down, pretty simple, and the team was like, okay, why is it not working? We are quite lost. And they initially thought that, so this is the AWS console, and they logged in, and they thought, okay, maybe it's a key issue, and an IAM key. So they deactivated the key and created a new one, and they said, okay, is it working better now? And unfortunately, it didn't work better. So they tried something else, and basically they said, okay, it's obviously a permission problem. It's read-only. We're pretty sure it's going to be that. So basically, they attached a much larger policy. In this case, administrator access. To be honest, it wasn't administrative access that they added, but it was very similar. And now they waited like 5 minutes and started to work again. And they said, okay, it's fine, it's good enough. It's the weekend, it's the night. We'll remember, we'll tell the guys on Monday, so they can revert the things and all the changes and make the changes in Terraform. And anyway, they knew that the team had everything on Terraform. So they were pretty sure that anyway, it would be seen by the CI/CD in place that was running Terraform plan and apply every hour or so. So basically, what happened in that case? So this is very similar. This is the same code. It's the same thing that they did. And if you Terraform apply after the changes I just made, so I rotated a key and I created a new one, and I added an administrative policy to an IAM user that was previously read-only. And if you Terraform apply this, what do you think will happen? Too bad, nothing. Because in this case, Terraform can see only what it manages. So it has a very precise scope, and the scope for Terraform in this case is just this. Like they have a user, they have a key, and they have a policy attachment. If you don't specify more than that, it cannot see that you attach something else or that you rotated the key that is mentioned on this line. So basically, in this case, the night shift team forgot to tell about the changes they did on the weekend back on Monday, and nobody saw the changes, and that microservice kept running with administrative access for weeks before someone accidentally detected it. So if they had drift control, as it worked differently than Terraform plan and apply, what would this team had detected? So drift control has a scan command, and you fit it with a lot of states. So in the case for this demo, you have IAM, VPC, and S3 with 3 states. It can work with S3, HTTP backend, etc. But here it's local for it's easier. And so we scan for resources, and basically we will output that this key definitely is not covered by infrastructure as code. And so there is a drift. In this case, you have the ID of the key, and you have the user that is linked to this change. So the whole thing with the Terraform language, like AWS IAM access key, it's the resource. So it should be very easy for you to link all the changes. The tool also bring some numbers, some data for you to crunch. It's quite cool, like code coverage. Like it's all the resources that you have on your AWS account compared to what you have on your state. So you can see here that we are starting with 85% coverage with the manual change that we did. So we can have some like bounties, like improvement. You can grab that, etc. We'll see this in a few minutes. So that's the kind of things this team could have seen with using drift control. So that was the first story, and it ended well. It ended well because somebody detected it purely by chance. But well, imagine if what could happen if a microservice with administrative access running on AWS in production could, if this microservice had a security issue, that could be terrible. The second story I'll share today is about, at the beginning, the pandemic last week, oh, no, last year, people started to work from home, and some people from a team I know couldn't connect to the company. And they opened a ticket, but they didn't want to wait. IT was like, I don't know why it doesn't work, etc. So those two people got upset, basically, and they asked some managers to do something like, we need to work from home now, do something. And one of the two guys had enough credential to open up the security group, and it solved the issue and for his team. And definitely it was, the guy was like, my goal is just to help my people work from home. It's we are on a degraded situation, and obviously I will tell the IT guys tomorrow, because I know I did something manually, etc. Problem is, the person forgot about telling the others, and basically what the guy did on the security group. Sorry, I forgot to show the code for this, for those of you who are maybe not familiar with Terraform. So this is a resource, a security group. So it has a name, it has a tag, description, whatever you want, and you have rules. So this is basically allowing only SSH on the local network 10.0.0, etc. And this is attached to the security group ID that we created here. There is different ways to write security groups. We'll see why in a few seconds. But in this case, they wrote their security groups and rules like this. And basically, our guy had the great idea to create a new rule allowing all traffic from anywhere and call this temp. so he saved the rules, and guess what? It worked. So obviously it was something like whitelisting an IP or VPN or whatever it is, a blocked port or a mobile IPv6 network. I don't know, but it fixed the problem. So his team, they had everything on Terraform, and they know what happens when you modify, when you add such a rule manually on AWS. Well, unfortunately, it doesn't do much. You have 0 added, 0 change, and 0 destroyed. Why is that? It's because basically you have two ways to write your Terraform security groups. And one is to separate the rules and the group and attach them one by one. The other one is to create blocks of ingress and egress rules directly in your security group. And unfortunately, they choose the other one. So in this case, a rule is a different object as seen by Terraform. So it's not Terraform's fault, it's just the way it works, because its scope in this case is a rule and a security group is a security group. And this was quite new to this team that unfortunately stood like this for weeks again, like with the main security group open to the world for all ports. Had they used Drift CTL, Drift Control, they would have immediately got this output saying, oh, your state, your Terraform state accumulated in maybe a different environment or whatever. For this security group, they have both two new rules. One is allowing everything for IPv4, and the other one is allowing everything for IPv6. Definitely it should ring a bell on your side, and definitely you should put that kind of tool in CI, like having a notification if something like that happens in your case. So so basically, it stood like this for a few weeks, and someone just tried the tool, or I don't remember exactly how it works. If it was by pure chance, or if they run a tool to check for security implications of the setup. But in the end, they really thought that Terraform, the intention, asking for a specific state would prevent the reality from catching them if Murphy jumps, and Murphy jumped big way, big time. So the last story for this part of the talk is about a team in London. They are still there were like 100 developers, and they were building a plugin for some enterprise thing, and every hour or so the plugin was uploaded to S3 for some QA, sorry, and well, some testing, and then it was just dropped. So it was 100 of gigabytes a day, uploaded, processed, and dumped. It was the way it worked, and it worked well, and it still works well. Thing is, the bucket was created quite simply. In reality, it was using a module more complex, etc. But in the end, for the talk, it can come down to this. So it's basically a simple resource S3 bucket, and it has an ACL like private, but it could be a bit more complex. It would not change the situation. So at some point, another team came in and said, "Okay, we need to our job right now is to add a lot more compliance to our IT and infrastructures and cloud infrastructures, and basically we are enabling S3 versioning, among other things, security-wise." And so S3 versioning will be enabled on all your buckets, all the buckets you are using. So the team I was talking to, they told them, well, okay, cool for many buckets, but on this one that I just mentioned, it's quite useless because we just upload things there just for them to be deleted. So really, it's just a waste of money. So you shouldn't enable S3 versioning in this case. So the team said, okay, cool, thanks for mentioning it. We will not do it. So what they did when they came back home and started to work on their big compliance project, they used Boto and Python scripts, etc., with a nice exclusion list with all the buckets they needed to avoid. So the team in London, the team of developers, they had all their resources, all their S3 buckets running on Terraform. It was running in CI, like in Circle CI or something. And every hour or so it was running. So they were very confident that things were going well, because if it was changing, it would be noticed to them. And the other team as well was like, yeah, sure. If our script crashes, we will know about it. So basically what happened in this case, S3, so that's our S3 bucket for DevOpsDays Kraków demo. And basically what they did using Boto in Python is simply, it's not there, sorry. I created my screen too big. Yeah, bucket versioning, and they enabled bucket versioning, basically. So what happened? So here it's enabled. So basically, if they had driftctl in place, they would have known immediately that a change happened, because, oh, this is a change resource. So the script failed from the compliance guys. And unfortunately, if you go to S3, and you apply, same demo than previously. You can imagine what's going to happen. Nothing. It's not going to be seen for the very same reasons that I mentioned previously. So let's go back to the slides. So we could tell hundreds of stories like that. You probably had a ton yourself in your recent experience. Manual changes from scripts to microservices to users to night shift IT guys, outsourced guide. I don't know, yourself, you are testing something on the console and you have this IPv6 rule automatically created on your security group. And this will create a problem tomorrow or in 2 months. So the tool DriftCTL has some nice features as well, like you can have just an output like this, so you can integrate it on your own scripts or your own APIs, your chat bots, anything you want, or other scripts. Like something I like to do is output the coverage in using JQ in this case, but you can send it to Grafana or something, so you have nice scripts, graphs, etc. So yeah, you can do whatever you want with this. We have filters as well. So here you can filter, it's using GMSpath. If you are used to the AWS CLI, it's the very same system. So if you want to report only on a certain type of resources, certain tags, anything specific to your case, you can do it with the filters. So it's very easy to have a quick report on specific areas. Let's say you have a very large infrastructure and you want to report only on IAM keys. You can do this with the filters. The time is running. So we also have a drift ignore. It's very close to the gitignore file you already know. So if you have a lot of unmanaged resources, which is probably what's going to happen if you messed a little manually with your AWS account, you can add all the resources that are manually created, like the IAM user for Terraform, probably manually created. So you can add them, resource, a name in this file, and from now on, it's going to be ignored. So, and then you can work on this. You should like add this file to your own Docker image for DriftCTL that you're going to run maybe on CI, CI integration, because I highly recommend you to deploy DriftCTL in CI, because it will detect drift in your own case where it's important. So if it's a recurrent task like a cron job or something, you will know like in 59 minutes if something changes, it's cool. If you have much bigger infrastructure, well, do it like every I don't know, half day or something. But you can have it on your pipeline or your infrastructure as code pipeline as well. Like at the beginning, running at the beginning, it makes sure that the rest of the pipeline will be in the situation that is not correct compared to what was expected on your account toward the state. So Terraform apply did not include some things in your state, etc. But at the end of the run, if your case is like having a lot of scripts running after Terraform apply, like things that change, create snapshots or whatever, it can be very interesting to have drift control at the end of the run as well. So you ensure that all the changes that could be made after Terraform are still under control. So it's definitely up to you for the different use cases that you can have. We have a lot of different examples on the website, on docs.driftcontrol.com. We have an orb for Circle CI, we have a GitHub action. We have a lot of documentation for almost everything. So I highly recommend you to ship drift control on CI, so you get so you get notification when it's important. So basically, DriftCTL, yeah, it's open source. It's written in Go. It has the support that you just see. AWS, we have GitOps support as well, filtering, ignore, etc. It's on GitHub, cloudskiff/DriftCTL. We have a Discord, community Discord. Join us. We are definitely community driven. If you want to help fight drifts, join us on Discord, talk to us. We are there like 7 days a week and 24 hours a day. So driftcontrol.com/D will redirect you to the correct URL. And basically, if you join the talk during the talk, what's to remember is that basically almost everyone experienced infrastructure drift at some point recently, and that we built DriftCTL as an open source tool to help increase the knowledge and security of automated cloud infrastructure. So thank you for your attention, and thanks for watching, and see you for the questions now. Bye-bye.